Hello friends. Today we will solve few questions from NCERT book. Um, Let us start with the first question, question number 3.1. This question is based upon the concepts of point object or particle, which we call. Now, please bring the definition of particle in your mind. What was the definition? A particle is something which is having no size, but it's still having some mass. Okay. So first question is whether you have to decide whether a railway carriage which is moving between two stations, is it a point object or is it not? Now, in this question, the question is not very clear because uh, the distance between two railway stations is not mentioned. The two railway stations could be Delhi and Bombay, or the other two stations could be Bombay and Thane. If Bombay and Thane are there, then the distance is very less and the size of railway carriage becomes large. But if the distance from Delhi to Bombay is there, then the distance is very large. The size of railway carriage compared to that becomes very small. So it is not clear very, but still we assume that the two stations are very large distance. So uh, the distance covered is very large, and therefore the railway carriage can be considered like a point object or a particle. Next is a monkey who is sitting on a bicycle doing circular motion. Again, the circular motion, the radius of the circular motion is not mentioned, but if you have ever seen a monkey, okay, nobody has seen such a monkey, but if you imagine a monkey sitting on a bicycle and the bicycle is taking very large circular path, then the monkey sitting on it comparatively small in size, so monkey can also be considered as a point object or a particle. Now the next one is interesting. It is a spinning ball. Now spinning means rotating ball. Now if you want to study the rotation of anything, okay, how do you come to know that whether the body is rotating or not? There should be 2 points on the body which are moving uh, with reference to each other, with contact to each other, and these points could be like this. Now just see, in this case there is a ball and I have marked 2 points. If the ball is doing rotational motion, then one point will go like this, other point will go like this. So at least 2 points have to be there. Now if any object is having 2 points, definitely it is not a point object, it is at least having 2 points. So a spinning ball cannot be a point object. Next one is a tumbling beaker, a beaker falling down from a table. Now what is the size of the table? It's about say 1 meter, 1.5 meter, and a tumbling beaker, it is a size of 10 to 15 centimeter. Now this makes the tumbling beaker 10 times smaller than the table, and so the sizes are quite comparable. It is say that if the table is 1 meter and the beaker is if the table is 1 meter and the beaker is 10 centimeter, that makes 0.1 meter. Now these sizes are quite comparable to each other, so we cannot say that a tumbling beaker is a point object. Coming to question 3.2, the graph based question, and the very first requirement for this question is to read the question very carefully. Okay, we have two students who are doing some kind of motion in this question. They are starting from the school and going back to their home. This is how the question is presented in the NCERT book. Two students, A and B. Now in this graph you will be required to draw 4 lines. Points Q and P are mentioned. So from those lines you draw, from those points you draw 2 horizontal lines, and from the tips of the graph you again draw 2 vertical lines that will be on the time axis T1 and T2. Okay, so after drawing these 2 lines, reading of the graph, see, graphs, they are having their own language. So in order to grasp the data given in the graph, you will have to do a little modifications. Now the first question is, who lives closer? This is a distance versus time graph. Now who lives closer to the school? See, the one who has covered smaller distance is closer to the home, and one who has covered larger distance from school to home is living away from the school. So who lives closer? Obviously you can see that who's on distance axis, who is having larger distance covered. We can see the graph of B and the graph of A. Student A covers a distance up to P, while student B covers a distance up to Q. So student A has covered smaller distance, so he lives closer to the school. Okay. Now again coming to question B, which student starts earlier? Now again you can see the graph on the time scale. The student A has started from the school, from the origin, while B has started its motion sometime after the original time. So who has started earlier? Obviously A has started earlier. Now, who walks faster? This is a distance time graph, and the slope of distance time graph will tell you who is walking faster. Compare the slopes of graph A and graph B. Which graph is more slopy? It is graph B which is more slopy. You can see from it. There is no need of any calculation to calculate the speed. But graph B is more slopy. So, who is walking faster? It is student B, whose graph is steeper. It is having more slope. So, B walks faster compared to A. Now, do they reach the home on in the same time or different time? Obviously, uh, student A reaches home at time t1, student B reaches the home at time t2. So who is reaching earlier? A who is reaching earlier, B who is reaching later. So they will reach at the same time? No, they will reach at different times. And the last one, who overtakes who? See, A started the motion earlier but reaches the home later. B, student B, starts his motion later on but reaches the home earlier than A. Okay, so it is very obvious to know that who is overtaking whom. It is student B who is overtaking student A. Coming to question 3.3, it is again a graph based question, and first you have to decide what scale you have to draw on the graph. There's a woman who is going to the office. She starts at 9 o'clock, so our graph will also start at 9 o'clock. Okay, now what is x-axis? X is the distance from home, and t is the time which she is taking from home to the office, sitting in the office, and then again going back to home. Now, first thing we need to calculate is the time taken by the women to go from home to the office. This is how we calculate the time. Time equals to distance upon speed. Distance is 2.5 kilometer. Its speed is 5 kilometer per hour. That gives you half hour as the time taken, which is equals to 30 minutes. Okay. Now, first thing we have to do is to plot this 30 minutes on the graph. Okay. The distance covered is 2.5 kilometer and the time taken is half hour. So where is that point on this graph? This green spot is that time where the lady is reaching the office, and now we start from 9 o'clock and reach this point, and this is how we draw the graph, starting from the point of origin to the point which is marked, and there she reaches the office. Now when she is in the office, the distance is not changing but the time keeps on passing. So the remaining part of the graph will be a straight line, it will be a straight line, it will be a straight line till 5 o'clock. At 5 o'clock, she again starts going back to her home, but this time she is taking an auto rickshaw, and the speed is 25 kilometers per hour. So first we need to calculate the time taken by the woman to reach the home. This is the time, the calculation of time, distance upon speed, 2.5 kilometer, the speed is 25 kilometer per hour, that is 1 by 10 hour, or 6 minutes. So she is taking 6 minutes to reach back her home. So now we plot a point, that red point do you see? What does that indicate? Which time is shown by it? It is 5 o'clock and 6 minutes. So there is the point, and the last part of the graph, we join that top of the graph with this point, and this is how the graph is drawn. This is question number 3.3. Now question 3.4, it is basically not a numerical or a concept based question. It is a kind of puzzle. You have to calculate it very consciously with full awakening. So this one I'm leaving up to you. This is mind well, this is not a question or numerical or conceptual one. This is just a puzzle. Okay. So very easy, but it's very difficult to get the proper answer during the first trial. Give it some number of trials, and you will be fully satisfied when you get the answer by your own. Let us go back to the next question, 3.6. The first thing, please read the question very carefully. The first step to solve any numerical is to read the question carefully. When you read the question, what you get is this: something is moving with a speed of 126 kilometers per hour. The distance covered is 200 meters, and this distance is covered on applying the brake. That means at 126 kilometers per hour something is moving. The brakes are applied, and after the brakes are applied, still it takes a stopping distance of 200 meter, or the distances of 0.2 kilometer. And because after this motion the body comes to rest, that means the final velocity of the object is 0. So this is something which you get from the question. This data you will get from the question. Now you have to find that which equation of motion is most suitable to solve the question. First we find out the acceleration, and then we find out the time. Search that which equation will be most useful to solve the question. V square minus u square is equals to 2as. This equation, only this equation, will be able to give you what is the acceleration of the body. Now just put the values of v, u and s, and then find the value of a. This is how, when you put the values, you will find the value of acceleration, not exactly acceleration, it will be retardation, and this is what you get. Acceleration in kilometers per hour square, it will be 39690 kilometers per hour square. Converting this kilometers per hour square into meters per second. See, generally what we do in physics is that the units that are used in the question, the same units are used in the answer as well. So because the distances and everything are given in terms of kilometer per hour, the answer must also be in kilometer per hour square, but because in the answer it is given meter per second square, so we convert this 39690 kilometer per hour square into meters per second square. How to convert kilometers into meters? Multiply by 1000, and you have to divide it with hour square. So to convert hour square into second square, divided by 3600 twice, and this is what you get. It's minus 3.06 meter per second square. Now the negative sign here suggests that the acceleration is negative, which definitely means it is not the increase in speed, it is decrease in the speed, or in other words it is simply retardation. Now finding the time, again search for an equation which will give you uh, the time in this question. How can you find the time in this question? Search out all the equations of motion. This is how you do it. The equation v equals to u plus at or t equals to v minus u upon a. Put the values in this equation. Putting the values all in kilometer per hour and kilometer per hour square, this is what you get. 0.0031 hour. The time taken is 0.0031 hour. But again, the answer at the back is mentioned in some different units, so we have to convert it into seconds. So how to convert hours into seconds? Multiply by 3600, multiply it with this number, and this is what you get, 11.4 seconds. Okay, this is how you find the time. Thanks for today.